Hello, I'm Daniel Kordemosh, an online student for the University of Advancing Technology, and this evening we will be going over the 6 board objectives for the Digital Maker and Fabrication degree path, as is the degree that I will be wrapping up this term. Now, this is my website, Dragonspire R&D. This is where I've been keeping all the information pertaining to my student internship project, other projects that I've been working on, and of course a section for the boards. Now, in this section, a quick overview, we'll have a total of 6 objectives, each one with 2 to 3 projects, and each project will have its own subpage showing off some of the design work, prototypes, code, and any additional documentation. Now let's get right on into it. For objective 1, it's going to be the prototypes that are patent ready. Now, starting off with Project Odin, my SIP. This is something that I developed from the ground up, running against prior art, making sure not to infringe on anything currently on the market, and coming up with that fully functional prototype by the end. Also, the step latch saw a need for people who have potential back injury not being able to bend over to open up the kennels for their pets. So had to come up with several different designs, went through several phases of prototyping and dimensioning everything out, getting it ready for patent. Moved on to objective 2. This is more the technique of building a prototype. The mobile dynameter, this was a project that I was actually contracted to work on. Did it in Mastercam, dimensioning everything out, was given very rudimentary designs at first, had to look over some safety issues, but through the process, made a 1/5 scale prototype out of a PLA, and later redesigned it in Fusion 360, just doing more structural testing and checking over some safety issues that I saw. Also, the Thomas robotic car. Designed and built the entire circuitry in Tinkercad first, allowing me to do it all in a digital controlled environment, run my code, and then moved on to breadboarding each of the circuits for rapid production before actually soldering everything together. Objective 3. This is where form meets function. Starting us off with the wave chair, went for a unique design to a high top style chair, as can be seen with that zigzag or wave pattern in the front. Now, this also provides a function, as people with different heights will have different leg lengths, so they may not be able to just put their feet on footrests. They might just be dangling there, but with the wave, it gives different levels for a person to rest. Also, advanced drone control. This was a Greenlight project that I worked on in PDS 300 and 450. Worked on multiple pieces, but the main one that works for this objective is the control grip. This had to be ergonomic. Had the team want something that looked kind of Formula One racing style to it, but still be able to run the circuitry within it that is all hollow, and also all those points are where the buttons for the drone control will be. The die-cut workstation is the next project for this objective. It's a furniture design that I came up with, looking at the increase in DIY and advances in crafting, specifically in the die-cut workstations. Need to be able to have several slots for different vinyl materials, cardstock. Had that slide out on the right that would be on rails for plenty of tools and smaller modules, while still having a good workspace up top. Now, objective 4, evaluation of material. The tabletop catapult was a torsion-style catapult that I designed in SolidWorks. This allowed me to do motion studies and also stress testing. This allowed me to pinpoint some breaking areas, so I would be able to reinforce them, and also look at the maximum tension for spring for that catapult. Mobile dynameter was also a similar process. As I designed it, I knew that the prototype being PLA was not going to be strong enough to have a car up there, So this need to eventually have the full-scale product made out of something more like a 6061 aluminum, so it could be light but also strong. Also, would have to integrate high-speed bearings into those rollers as they be under high speed and tension. Also, once the patent lapsed from the person that contracted me out to initially work on the designs, came up with a lower profile design myself, correcting some of the safety issues. Now, the Hive memory box. This is just a simple project where it has a snap-fitting lid. Looked at different filaments that I could use for it. ABS is more durable on that. But I also had to think about how the layers were going to be printed would cause increased friction, thus increasing my tolerances used. Now, Objective 5. This is where electronics get brought into this. The autonomous robotic car was a project where I used a ultrasonic sensor to take in a range from the car, process it through an Arduino microcontroller, and then adjust the motor controllers to slow down one side or the other, causing avoidance of the objects ahead of it. Simple Simon, similar project, but instead of being autonomous and using a sensor, it's a little game that outputs a signal to the LEDs, and it'll be in a sequence that the user has to input back, trying to get that correct sequence using little buttons. And of course, Project Odin. This, I outsourced the optics, but still had to build the bridge. That's that central module that takes in all the information from the optics, and by user-selected buttons, shifts the channels through a relay system, sending the digital or analog signal up to the display. And wrapping up with Objective 6, that agile development, coming up with that minimally viable product in the end. The advanced drone control, as I said, worked on multiple different pieces. Some of the pieces I was working on had been initially developed by other students, and I had to go in and correct different spots. Also, I was getting the designs to my project manager that was physically at UAT. We would get the piece printed off, would do a quick test slice sometimes, just make sure everything fit. And as we discussed over Teams, we could figure out what improvements had to be made, and I would get the next set of files, sometimes within 15 to 30 minutes, back to him so we could continue on with that project. And of course, started with Project Odin, going to end with Project Odin, as is my SIP. Had a few roadblocks as I was working on it. Different design features were just not going to work out, or I just had to come up with a new way to achieve the same goal. Then finally coming up with that minimally viable product in the end. This has been the 6 objectives for the DMF degree path, and my projects that have been featured for achieving those requirements. Thanks for your time.